you can know me as Nauktur from the internet, and if you go to nauktur.pl, this presentation is already linked there, so you can follow the links in the presentation, or you can do that later, obviously. This is another run of this presentation. I managed to add a lot to it, so if you recognize the beginning, it's just the beginning that you recognize. Everything else is updated with some important new additions. So first, let me start with telling you I'm not a hacker. So compared to the previous presentation, this one's going to be done by someone who's not qualified to talk about it. And this is very crucial. I thought I'm a hacker when I was 13 years old, and these were my first 5 lines of JavaScript that I wrote, which if you run this in Internet Explorer before XP Service Pack 2, you would crash Explorer to the point where the system no longer displays any windows. It was a lot of fun at school. Yeah. With that, I think this now qualifies as a presentation about security, because I've already given you a demo of something that used to break your machines, and now it doesn't. OK, now to the point. Right. Let me start with explaining what formally I'm going to talk about. And I'm going to talk about hardening. Hardening is about making it harder for the hacker to break your application, to steal your data, or perform any actions that you would otherwise not recommend. This is a very general computing term. But I'm going to talk about development hardening. So what you can do to your development processes and tools and techniques you use to make your app significantly more secure. So to start with, you don't need to know a lot about hacking. I recommend getting to know some hacking. It's fun. But you don't have to have any accumulated knowledge other than a few buzzwords. And this is going to work for you. You just introduce new tools and practices to your workflow that help you ship significantly more secure applications. And that's the goal. You want to close big gaps in security with as little effort as possible. Yeah. You're still responsible for your code. So this is not about me telling you, hey, install this thing, and you no longer need to consider security when writing code. You should be a security-aware developer. I would happily promote that in a separate presentation. This is not about it. OK, so let's do a recap of threats we're dealing with here. We're all web developers. So we're dealing with the most popular one, which is injections. There's SQL injections, but there's also NoSQL injections. You can do injections in MongoDB, if you weren't aware. There's malicious packages, of which you've probably heard. OK, who hasn't heard about malicious packages on NPM? Raise your hand, please. Yeah, I love it when no one raises their hand when I ask a question. And this is intentional. So everyone heard about it in the news. Now, how do we defend, right? OK, data theft is an ugly one, and with GDPR, very expensive one all of a sudden. We have cross-site scripting, the most popular one and the most fun to learn. Do go type in XSS game in Google and get a game you can play and learn about XSS. It's a lot of fun. Cross-site request forgery. Hey, I heard this term today, I guess. Right? Were you paying attention? Remote code execution, RCE for short, is when someone types some code into a form and posts it, and this code runs on your server. One of examples. And this one is a very niche one. It's regular expression denial of service. I said it for the first time, like, correctly. Yeah. It's called RDoS for short, and this one is only important because you're going to see it on daily basis if you start running the tools, and it's not really that important unless you're Cloudflare. Yeah. ASCII art is also fun. OK. yeah, I said you can do injections to MongoDB. So this is going to be the one that I'm going to show you. Imagine you have like a collection and you do find on it and you pass something that the end user can control what the fields are. So in this case, you just expect ID equals 1, it goes to the find query, and you get the first element. You can obviously like skip stuff, so that would be a vulnerability potentially, but there's better stuff to do with it. You can do this, and it's gonna stop the process of MongoDB responding to you for 20 seconds. If you do 5 of those, you're gonna exhaust the pool of connections. So you've stopped the app from requesting the database for 20 seconds with 5 requests. Pretty good. There's a whole talk about it, but I've summarized it all for you. So yeah, but watch it. It's fun to watch. OK, now to the point. So development hardening. Let's focus on your workflow around using NPM and dependencies and builds and stuff. So first of all, I need to start with this. Don't use evil. Evil is evil. OK, there's always someone to shout at you about it. So you can install this security plugin. And this security plugin is going to give you errors when you use evil in any of its evil forms. But it will also spawn hundreds of warnings like this one, which says you're using a reference to take a field from an object in a way that could potentially mean it's a long story. I'm going to show you. Yeah, so you can ignore most of these warnings, but let me show you why these are warnings at all. So imagine this code in Node.js. You take requests, the popular deprecated module for making requests. It's not deprecated for security reasons. It just happens to be a thing that has methods, .get, .post. So I want to choose the method. And then I have this payload to send, or in this case, this would be used as a URL. But yeah, assuming someone was able to send this console log, so it's a case where someone's trying to make a RCE, right, remote code execution, on your code. So what would be the method they need to pass to make console log run? Who knows? Yeah, it's a bit tricky. But function constructor is also a function, and it accepts a string, and it produces a function from that string. And then you can run it. So these 4 lines of code are exactly the same as running the evil function. So yeah, it's something to be aware of, but most of those warnings are going to be false signals, so you got to be patient. Next, well, npm install is a remote code execution, right? You're downloading stuff and running it. Mostly the post-install scripts, so let's not run them. But some of those post-install scripts are necessary for compiling like most of Google stuff on npm if you need to use their protobuf. So what do we do about that? There is a great simple package called allow scripts. You install it, you define the packages that you want to let run post-install scripts in the package JSON. If you're not lost already, I'm just going to finish off saying allow scripts is going to run only those scripts that were listed as trusted. And that's it. So this is a fairly simple solution to a very big problem and very rarely used. There is another way. You can use your CI. So your CI is probably nowadays running Docker containers and destroying them every time a build finishes. So we can run npm install, or actually npm CI. Run it everywhere other than your local host. This is a good choice. And you can just take Node modules. So if the image you're using in CI is the same platform, the same Linux flavor in most cases as your production, you can just copy node modules, paste it to the deployment, and it works. So in this case, you're at least safe from packages that would use an install script to go and edit etc hosts to replace some host with a malicious IP address, right? This is useful, even on top of the previous one. OK, and now the biggest splash I have to show you is NPM audit. Who is seeing NPM audit for the first time? Raise your hand. Yay. OK, very few hands. Right. So NPM audit has this fix command that will install newer versions of your dependencies that are vulnerable to known attacks, in most cases, unless those versions don't exist. And this brings me to a story that happened to me and a lot of other people. Mostly my team at Ignite at this point that I know of. So I'm running an integrations team at Ignite. And we're building Node.js apps. There's over 30 of them in production now. Pretty separate apps. Each of them has 3 of dependencies. I'm not going to bring the node modules heaviness joke again to the stage. But we have to do mass maintenance over those applications because we want to keep all of them up to date with everything. So we also started running the audit check. Actually, we started running it before NPM audit existed, because before it was Node's security project. And that worked for us. And then it turned out to be very frustrating. So the cycle of what I do at work is I get frustrated, I find a way to automate it away. I spend a bit of time happy, and then I find another frustration to work on. We wanted to run audits in CI so that if we have a vulnerable dependency, we won't ship it to production, right? So the build goes red whenever a dependency has a vulnerability in it. And now imagine that a very small package somewhere in the dependencies of your test runner that you only ever run outside of production has a regular expression denial of service attack on it. So is that a problem? No. We want to ignore that. We don't even want to attempt fixing it because this regex never runs on user input. So how do I do that? How do I manage my security decisions if NPM audit is telling me, you have more than 0 problems to solve, now let's crash your build, and everything's red? The other solution to we found a solution, an intermediate one, to ignore some of those or to work around it in various ways. But then, if a vulnerability shows up and it's a real one, and it's the last day of sprint, we're not going to ship it until after the sprint, and we need to at least put it in staging to show off the great features we've built. What now? Well, someone's going to ignore the issue to make the build green to get it deployed to staging automatically. And then who's going to remember on the next day after all the celebration that we need to now unignore the thing? So that's how I arrived at NPM Audit Resolver. NPM Audit Resolver is a wrapper around NPM Audit, which has 2 commands. One is check audit. It's the one that you're supposed to run in CI. And it's gonna do the same thing. It's gonna fail your build if there's new vulnerabilities, but it's also gonna take your own decisions about what you want to ignore into account. And there's Resolve Audit, which is an interactive tool to make those decisions. And yeah, spoiler, it also supports Yarn for like a few days. So what does it do? You run Resolve Audit, and you get this. It says that you have a low-dash version that is vulnerable, but it's in dev dependencies, and you can run the fix. This option shows up if it's available. You can get more details from NPM audit output. You can obviously like do the stuff like skipping it, but the interesting part is here. So remember demo day hangovers? You can say, remind me in 24 hours. It's not configurable. It's going to be ignored for exactly 24 hours and then fail again on the next day. What if it's a weekend? Well, if a build turns red over the weekend, does it make a sound? You can ignore pass. So you can ignore an entire problem with this crucial thing. I think this is the best feature of NPM Audit Resolver, and I can say that because I wrote it. If you choose to ignore it, it's only going to ignore this particular vulnerability and this particular dependency of other particular dependencies. So if the same problem with the same dependency happens elsewhere, like not in dev dependencies or as a sub-dependency of something else, it's going to be brought back to your attention again. And you can obviously remove the dependency because, well, I added this because I would spot that Resolve Audit is asking me what to do with stuff that I'm no longer using. So this helps me also clean up dependencies sometimes. Okay, so there's an RFC open and an ongoing discussion about making NPM Audit respect the decisions made in Audit Resolver. There's intent to bring it in, but we're discussing how to really get it into NPM. I've extracted the core of the package so that it's going to be easy to include that in other dependency managers. And now it has experimental Yarn support if you're running with Yarn. It should do its job. Let me know if it doesn't. You can use it now. It's not the code that runs in production. It's a tool, so it's safe to use. And I've been using it for almost 2 years now, in various forms, so it's safe to use. And your feedback is welcome. So altogether now, there's a script you can run. This example is compatible with GitLab CI. You can run ESLint with the plugin. You can run npm CI and ignore scripts and limit the dependencies you install to production dependencies. This is probably the safest option of what to ship to production. You can allow scripts to run the ones that you have to. And then you run the check audit command from NPM Audit Resolver. And the whole thing here uses npx because it's easier to show in a slide, but you don't have to. You can install it locally in the container that you're using for building and run those commands without npx. And I have this project GitLab CI job prototypes where this a version of this job is available to inherit from and configure a bit, and it just runs. And there's a secure dependencies package, which is useful when you don't have a CI with Docker and stuff. So you can build a tar file of your dependencies ready to roll. OK, well, that was a lot, so I'm going to give you a break to just regain your consciousness. Take a deep breath. Let's move on. Now we're at the front end. So cross-site scripting is a bug where the security guy from your company comes in and says that he can spawn an alert from your application where you didn't expect it. That's the most common use case for cross-site scripting. And there's a thing called content security policy, and I had a presentation about it in 2014. Yeah, big news, right? But content security policy grew a lot. You can now stop a lot of potential attacks. The idea behind it is if you have a cross-site scripting problem in your application, and you probably have, you just don't know about it yet, content security policy will stop it from being exploited. So someone can put some code that your backend will ship to the user in a runnable form, but then content security policy in the browser will stop it from running. This is great. There's some links. ContentSecurityPolicy.com is the first resource you need to look at. It shows browser support for everything. And it's just a header to your application. So should be simple, right? Why is no one using it? OK, no one is a simplification, an unfair one. It's being used, but it's hard to deploy. So I'm going to tell you how to do it. Content security policy has this version where instead of blocking stuff, it's going to report stuff to an endpoint that you specify. So build something that accepts JSON and puts it in logs and expect a lot of traffic initially. So you set it up and you run tests on your application and gather feedback. If you start getting content security policy violation from your app itself, it means you need to change your policy, right, to loosen it a bit, maybe. Some content security policy is better than none. So now you continue going to staging environment and let your other users or testers click through it on regular basis and see what you gather. Over time, you're going to have a content security policy that shouldn't block your application from running. So now you go to production, but still with the report-only version. One crucial information, I know of a big Polish company that run through this procedure. And then the endpoint that they used for receiving reports was deployed in more or less the same location as the rest of the application. And it got so much traffic that it was effectively the 20 minutes of downtime before it healed. So take that into account. It should be separate in case it gets overwhelmed with traffic from the browsers. You're going to see a lot of weird reports initially. And then when you're sure you're ready, you're not getting any reports from your own code, you can switch to content security policy header. That's going to be healthy. OK. Now back to service stuff. For Node.js, if you're really on a critical path for security, and you need to be very careful about the data you're transferring between modules, and you don't trust your own dependencies because there's thousands of them. But even for more valid reasons, there's two modules that could be helpful. Investigate them and see if they're helping your use case. This is very niche. Like I don't think anyone uses this at this point. This is early work on doing security with the assumption that your dependencies are evil. And this is work of Mike Samuel, who has a few more things around this topic. It's really deep stuff. It uses asymmetric cryptography for communicating within the same node process between modules. Fun stuff. OK, and the bonus at the end. So I was on a train, and I had this idea yesterday. So I built a firewall that is capable of recording your app's normal behavior and then blocking any module from making network requests that you didn't observe before. So the idea is if one of your sub-dependencies is leftpad, and the maintainer happens to decide, I want to take process.env, turn it into string, and send it to my server. That sounds like a good idea. It probably has some credentials for AWS, where I could then run my applications for free. This tool is an experiment. Don't trust it yet. This tool could potentially block that from happening, because this is going to be a request that happens on the code path that didn't access a network yet. So there is some work in Node Core to handle this, but it's very early work, and we're going to have to wait still a version or two before this even shows up as experimental. And this thing, I'm going to consult this with people. If you like hacking, you can try to work around it. For now, there's a way to work around it when you spawn a sub-process. That's a fairly obvious one, but this can be blocked in other ways. Anyway, a fun tool to experiment with, to show what could be possible in the future. And don't rely on it. It's a toy. OK. That's about it. So to recap, there's things you can do to your processes and tools that make your applications significantly more secure. You don't have to learn hacking. You don't have to invest a lot of time into getting knowledge. You can use existing tools and procedures to make your app significantly more secure. I said it once already. You can check the slides out, and I also do training every now and then, so that might be interesting to you, and thank you.